Okay, today we shall begin with the dimensional analysis or other dimensional analysis. Okay, and its applications. Before that, you must know the dimensional formula of different physical quantities. Okay, in terms of mass, length, time, and the electric current. Okay, that we have discussed last time. Okay, now see, this is the thing that is in your textbook, which is given here. First application is checking the dimensional consistency of equation. Now checking the dimensional consistency of equation, it means that the dimensional formula on left hand side, okay, must be equal to the dimensional formula of different quantities on right hand side, or we can say dimensions on LHS must be equal to dimensional formula on right hand side. Okay, how to do it now? See, the question will be given to you. Okay, say for example you are given one equation. Now see, equation will be given to you and different introduction of quantities will also be given to you. Say for example this is your equation. Okay, this is the equation that we want to show whether it is dimensionally correct or not. This is the equation. Okay, all the quantities which are there will be introduced to you. Say x is the final position, okay, or distance x, okay, traveled by the particle. X0 is the initial position, that is initial starting point. Okay, it starts from 0, so it starts from a point from x0. X0 is the initial point, so it is in meter. Okay, v0 is the initial speed or say initial velocity, whatever it will be description will be given to you. T is the time, a is the acceleration, okay, t again is a time. So different quantities which are appearing in the equation will be introduced to you. You have to just remember and write the dimensional formula of those quantities. Now you must know the dimensional formula of all these quantities. Now let us try to solve this. Okay, say for example you have this equation. Which equation you have? X is equal to x0 plus v0t plus 1 half a t square. This is the equation which is given to you. Now this x is the distance traveled. Distance traveled is you measured in meter. So on left hand side, we have x, that is distance traveled, and its dimension will be m0 l0 sorry l1, because distance traveled is measured in meter. So l1 t0. So dimensions on left hand side is in short l1. Each and every term on right hand side must have the dimensions l1. Now let us see. Now we talk about RHS. Okay, so first term of RHS, first term, now that is x0 is a initial position is measured in meter, so its unit will be meter, so its dimension will be l1. Simple as that. Okay, so this much you must understand. Now we go further. Okay, now we have second term v0t. You remember this, v0t is the second term. Okay, so second term is v0 t. So write the dimensions of V0. V0 is measured in meter per second. So unit is meter per second. So the dimension will be m0 L1 t raised to minus 1. Okay. Multiply by the dimension of time, that is t1. So t raised to minus 1, t raised to 1, they will be added, minus 1 and 1, so it becomes 0. So dimension of second term in short will also be L1. Now we talk about the third term. Okay, we talk about the third term. What was the third term? 1 half a t square. Now 1 half is a number. Number does not have any dimension. It is dimensionless or unitless. No need to write anything for it. A is acceleration. So for acceleration we write the dimensions m0 L1 t raised to minus 2. Okay. Then here this t raised to 1 and its square, because it has a square on it. See. Okay. So now you simplify this t raised to minus 2 and t raised to 2. So it becomes 0. So again the dimensions of third term will also be in short L1. So dimensions of first term on right hand side, dimension of second term on right hand side, and third term, they all are same, that is L1. Okay, so dimensions of each and every term on right hand side is L1, dimension of left hand side is also L1. So the given formula x is equal to x0 plus v0t plus half at square is dimensionally valid, or it is dimensionally consistent. When dimensions on left hand side and dimensions on right hand side, they are same, then we can say that the given equation is dimensionally correct. Okay, so this way you can easily calculate and check whether the equation is dimensionally correct or not. Okay. Now we go further. Okay, so the method is given, shown in the textbook. Okay, there is one another formula. Okay, equation is given to you. What is that equation? 1 half mv square is equal to mgh. Now this we want to prove that whether it is dimensionally valid or not. So what you are doing? You are writing the dimensional formula on LHS. Look here. Okay, mass is having dimension m1. Okay, then v is given. What is v? That is given to you. V is velocity. So L1 t raised to minus 1 and square of it, because it is square, v square. So simplify this, you will get m1 L2 t minus 2. Okay, now on right hand side it is mgh. Okay, what is that? mgh. M stands for mass, g stands for gravitational acceleration, and h stands for height. Now g is a gravitational acceleration, so dimensions of acceleration we have to write, whichever acceleration, we have to write the dimensions of acceleration only. So the dimensions of mass, okay, dimensions of mass m raised to 1. Then gravitational acceleration L1 t raised to minus 2. Then height is having unit meter, so L1. Simplify this. Okay, it is m1 L raised to 1, it is here. So here also 1, so total it becomes 2. So m1 L raised to 2 and a t raised to minus 2. So you can see the dimensions on both the side LHS and RHS are same. Therefore this given equation, that is 1 half mv square is equal to mgh, is dimensionally valid equation. Okay, then here there are different equations. Okay, you can simplify this also. Okay, write the dimensional formula of each and every quantity. Just you have to do that only. Here what is k? Read. What is k here? K is kinetic energy is equal to m square v cube. Okay, now energy, any kind of energy, the dimensions will be m1 l2 t raised to minus 2. Okay, this is the dimension of kinetic energy. Okay, so dimensional formula of kinetic energy is m1 l2 t raised to minus 2. Now on RHS you come. Okay, it is m square. So m, that is mass, so m1 raised to 2. Okay, v cube, now l1 t raised to minus 1 whole raised to 3. Now simplify this, what will you get? You will get l3 from here, so m raised to 2, so m raised to 2 l3 and t raised to minus 3. So both the side dimensions are not matching. On LHS the dimensions are m1 l2 t raised to minus 2. On RHS it is m2 l3 t raised to minus 3. So they are not matching, so it is not dimensionally correct, or it is invalid formula. This way you can go for each and every quantity. Okay, let us say I use this third one, k is equal to ma. Okay, k is having same dimensional formula, that is not going to change. K is equal to, its dimensional formula is m1 l2. Okay, m1 l2, again I am writing. Okay, k is having its dimensional formula. Okay, m1 then l2 is m1 l2 t raised to minus 2. So these are the dimensions which are fixed for each and every sum a, b, c, d, e. All the sums are having the same dimensions on left hand side. Now third I am trying to solve ma. So dimensions of m is m1. Acceleration is what? Meter per second square, so l1 t raised to minus 2. It is simplified only. This is the dimension on right hand side. Okay, so dimension on right hand side is not matching with the dimension on left hand side, so it is not dimensionally correct equation. Okay, similarly you can go for this all. Okay, and try to solve them. Okay, now there is another use. Okay, this is the second use, deducing the relation among the physical quantity. Again, very important one. We want to find out the relationship between physical quantities. Okay, now let us directly go towards the method of solving, and we take one question for it. Okay, yes, see, consider a simple pendulum having bob attached to a string. Now simple pendulum, as you must have seen, say this is the simple pendulum. A thread is there and it is tied with a rigid support, and one end the bob is kept or attached to the string that oscillates under the action of the force of gravity. So it performs the oscillation in this plane. Okay, suppose the period of oscillation of the simple pendulum. Now try to understand, period of oscillation means periodic time denoted by capital T. Period of oscillation, read and understand, period of oscillation of the simple pendulum depends on its length. Depends means it is proportional. This is a sign of proportionality, proportional to length. Now how does it proportionate, or how does it vary? We don't know. So L raised to A we write. L raised to A or X, whatever you want to write. Here XYZ is written. You can write XYZ, whatever. Okay, mass of the bob, it is also proportional to mass of the bob, so m raised to b. Okay, it is directly proportional or inversely proportional. How is it proportional? We do not know, but we write m raised to b. Okay, and acceleration due to gravity, so it is denoted by g, so we write g raised to c. Okay, derive the expression for the time period. We want to find out the expression for a time period using the dimensional analysis. Now this you must understand, or this much you can be able to write from the data, that time period is depending ત્યાંથી શરૂ કરવાનું, depending L raised to A, M raised to B, G raised to C. Whichever quantities are given, you write their powers as A, B, C or X, Y, Z. Whichever you write, whichever you are comfortable, you can write. Okay, now we move further how to solve it. Okay, say this way you can solve it. Okay, we have this t is proportional to L raised to A, M raised to B, G raised to C. This much you can find out from the data. Okay, this much you can write from the data. This is not required now. The figure just I have drawn for your understanding what is simple pendulum. Now see, first of all we remove this proportionality constant. Okay, so we write we remove this proportionality. Okay, this proportionality we are removing. Okay, so just we have to write a constant. So t we make is equal to k L raised to A, M raised to B and G raised to C. I have put a constant k which is dimensionless. K must be dimensionless. Their dimensions are not there, or it is unitless, we can say. Now write the dimensional formula on both the sides. Now t is periodic time, so it becomes m0 L0 t raised to 1. Okay, k is dimensionless, so no dimensions. Now length is having dimension L1, no mass, no time. Okay, so L1 raised to A. Similarly, mass is having the dimensions, that is m1 raised to B. Just you have to write this. Okay, mass means measured in kg, so it has only one dimension m1. Then gravitational acceleration, so it is having acceleration, so L1 t raised to -2 raised to C. This much you understood. Okay, now you just simplify. Okay, here there is only t1, so you write t1, or we can say all the three I write for the sake of understanding. Okay, here it is m0. Okay, m0 L0 t raised to 1. Okay, on LHS. Now here on RHS you try L raised to A, it becomes L raised to A. Then here it becomes M raised to B, because 1 B's are B. Then here again it becomes L raised to C. Okay, and t raised to minus okay, minus 2c. So this is the thing that is simplified on right hand side. Okay, now we can easily simplify the power. Okay, power can be simplified easily. Okay, try to understand this way. Here on left hand side the things are remaining same as it is, so we have m raised to 0, l raised to 0 and t raised to 1. Okay, that is remaining same on left hand side. Now move further towards right hand side. Now what is there for L? L raised to A is there and L raised to C is there. Now in multiplication powers are added, so L raised to, it becomes A plus C. A plus C. Okay. Now go for M raised to B only. So M raised to, just you write B. Okay. Now T raised to minus 2C. Okay. Now we have to compare the power whose base are same. So base L. Okay. Base is L. So we take the base L. Okay, here. So we can write A plus C is equal to 0. Okay. So we can write A plus C is equal to 0. Okay. Then you go for M. Base is M. So here also there is M. M raised to B. So B is equal to 0. We can write directly B is equal to 0. Okay. Now we go for the third one. Okay. So third one is the base T. Now see, T raised to minus 2C is there on right hand side. So we can say minus 2C is equal to 1. Okay. So minus 2C is equal to 1. So C is equal to, you can have one value, C is equal to minus 1 upon 2. Minus 1 upon 2. Okay, so we have the value of C, that is C is equal to minus 1 upon 2. Now this value of C you can place here instead of C. Okay, so A minus 1 upon 2. So A minus 1 upon 2 is equal to 0. So A is equal to 1 by 2. Okay, so you will get A is equal to 1 by 2. So all the three unknown numbers A, B, C we got. Okay, so we can write A minus 1 upon 2 is equal to 0. Therefore A will be equal to 1 upon 2 with positive sign. So A plus C. Okay, we had A plus C is equal to 0. Then B is equal to 0. Okay, and we had C is equal to minus 1 by 2. So if you place this value C is equal to minus 1 by 2 here, okay, then what will you get? A minus 1 by 2 is equal to 0. Therefore A you will get A is equal to positive 1 by 2. So all the values are with you. B is equal to 0. Okay, C is minus 1 by 2 and A is equal to positive 1 by 2. Now we go to our original equation which we had written. What was that? T is equal to K L raised to A M raised to we had B and we had written G raised to C. Now place these values of A, B, C which you got. So T is equal to K is a constant number, L raised to A is 1 by 2. Okay. B is 0, so M raised to 0 it becomes. M raised to 0. Anything raised to 0 is 1. And G raised to minus 1 by 2. So whenever there is 1 by 2 power we write under root. Okay. Now this is 1 only. Anything raised to 0 is 1, so no need to write 1 in the equation. So you will get K under root, because 1 by 2 power stands for under root. So L upon G. Why upon G? Because this is negative power. Negative power means this G has to go in the denominator. So G has gone in the denominator. Okay. And raised to 1 by 2, it means it has to be inside under root. So it has been written in the under root. Okay. So this is the relationship between L, G and L, that is length, G is gravitational acceleration and T is time. So periodic time does not depend on mass. Try to understand, because mass has been eliminated, or that term mass is eliminated from this whole process. Mass is not there in this last equation which we have derived. Okay, so the periodic time does not depend on mass. And from experiment the value of K is found to be 2 pi. Okay, so the last equation you can write this, you have to remember 2 pi is found. T is equal to 2 pi, okay, under root L upon G. So this is the final equation of periodic time. Okay, thank you.